Ever wondered why a 20-watt LED is way brighter than a 20-watt incandescent bulb? Why are there so many kinds of light measurements? What's the meaning of units written on all these boxes? This video is about how the light is measured as humans sense it, instead of measuring it as a physical entity. In order to understand the basic concepts behind different measurement types we see and how those are related to what we do in real life, let's do a quick recap. Color is a sensation. Light stimulates the sensors at the back of the eye to generate the sensation of color. Light is a tiny sliver in the electromagnetic radiation spectrum that those sensors are sensitive to. The sensors in the eye are not equally sensitive to all the wavelengths of visible light. Put simply, we sense or feel certain segments of visible light more than the other segments. Have a look at this graph that shows the sensitivity of the sensors in the eye to visible wavelength range. This sensor here is most sensitive to wavelengths around 420 nanometers. These two are most sensitive to the region between 530 to 570 nanometers. Now look at the region between 450 to 500 nanometers. The sensitivity is relatively low. The result of all this is how we perceive the brightness of different wavelengths. An amount of light in the high sensitivity region appear brighter to us than the same amount of light in a low sensitivity area. Therefore, just measuring the absolute amount of electromagnetic radiation, or in other words, just counting the photons, is not going to give us an accurate indication of how bright a light source to human eye is. Just measuring the amount of electromagnetic radiation, or the number of photons, is referred to as radiometry, and the unit of measurement is watt. Measuring the amount of electromagnetic radiation or the number of photons giving weight to how sensitive humans are to different wavelengths is known as photometry. In photometry, an amount of bias is given to each measured wavelength based on the reaction of a typical or an average human eye. This, of course, requires defining an average or a typical observer. If you want to know more about this, I have included a link to an article from the ASM network in the description below. So, in short, photometry measures light as we sense it, or light as per human sensorium, not just the number of photons a light source emits. And for those of us who are in visual arts, the power of a light source becomes truly meaningful only when it is expressed as a photometric measurement. In the past, the power of light sources were rarely expressed photometrically. All we saw on our incandescent bulbs was the number of watts written on. Nowadays, most decent brands provide some sort of a photometric measurement. If you see the light output of a light source mentioned in units of watts or wattage based measurement, that is a radiometric measurement. If you see the light output specified in candelas or a candela based unit, you are looking at a photometric measurement. The measurements expressed in lumens and lux are also photometric measurements. The table you are looking at, which I got from a PDF by Thor Labs, summarizes the measurement types and the units. And for those of you who want to learn more, I have included few links in the description below.